Okay. Okay, hey, we are going to start our new lesson. If you're not finished with the special triangles, you'll have to take that home because we are an accelerated class. I have to get through a whole year of geometry in 8 weeks. And it's hard to do. And we still don't get through everything I would normally get through, but I try my best. Okay, so we are going to find, today we're going to find the geometric mean between two numbers. That's an actual operation, you know. When someone says to multiply or sum or product, right? You know that you have to do something. If I give you two numbers and say find the geometric mean, that's going to be an operation, okay? But then we're also going to solve problems using relationships between parts of a right triangle and the altitude to its hypotenuse that uses finding the geometric mean. Okay? Does that make sense? Have I lost anybody? So, before we start, I want to go back to what a ratio is. A ratio is a quotient or a fraction where you're dividing two numbers, right? We could call ratios A to B, A dot dot B, A divided by B, or A fraction to B. This is the way you'll see me always write it, right here. When we did similarity, we cross-multiplied, correct? Yes. We're going to be doing that again today, cross-multiplying. Okay, so the geometric mean is that you take two numbers, multiply them together, and take the square root. If we are setting up the proportion, the two numbers go up and down, and the variable is you're going to see twice, both up and down. Do you see that? When I cross multiply, you would get x squared equals a times b. To solve for x, you would take the square root and would get ab. That's what this means here. Now, when you take the square root of both sides, you do get plus and minus. In geometry, because we're talking about lengths of sides, can we have a negative side length? No. No. Is there negatives on a ruler? No. So I throw those negatives out the window, and I just work with the positives because I'm talking about a length. But technically, if they say, like this one, what is the geometric mean of 8 and 18? That would mean you would have 8 up, you would have 18 down, you would have an x, you would have an x. So when I cross multiply, I get x squared equals, what is 8 times 18? 144. And when I take the square root of both sides, x would equal plus minus 12. And that would be, so with geometric mean, we'd have two answers on a standardized test like ASVAB. The military guys were out there. If you're going in the military, you would take the ASVAB test, or SATs, ACT, college entrance. But when we talk about triangles, we are going to only keep the positive number, right? So the definition of geometric mean is multiplying two numbers by each other and then taking the square root. And we would get plus minus. Any questions about that part? Multiply together, take the square root. Two answers, plus minus. Right? Okay, now I'm going to this next one. These gave the answers. I should have deleted them. Okay, so if I want to find the geometric mean of 36 and 9, what would I do with those two numbers? Or just multiply. I can set it up. I'll set it up if you want me to. 3 over x equals x over 9. So x squared is equal to, what's 36 times 9? You can go ahead and head on out. Yeah. What's 36 times 9? 3, 2, 4. You take the square root, but you get plus or minus, and that was probably 18 since the answer's right there. Now, I'm going to show you a trick I use because simplifying square roots can be a pain in the rear when the numbers get very, 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 very big. Right? Everybody agree with that? So, I'm going to set up my geometric mean of these big numbers. And I don't know if pain in the rear is actually a good teaching word, but it gets the point across. So I'm going to leave this as 35 times 175. And then I'm going to take the square root, okay? So x equals plus minus square root 35 times 175. Well, I already know a perfect square that goes into 175. What? It's 25. So I could just say, oh, this is 35 times 25 times, how many do I have? 6, yeah. So I'm going to go ahead and take this one out, right? And I get 5. So I have 5 square root 35 times 6. Now, I do know that 35 has some factors and 6 has some factors. Do they have any factors in common? Oh, wait a minute. This wasn't 6. This was 7. That's why. 25 times 7. Okay. So, now, but I know that 5 times 7 is 35, correct? Right? Am I losing anybody yet? So, this 7 can come out because 7 times 7 is 49. Square root of 49 would be 7. So what's left on the inside would just be this 5 right here. So what is 5 times 7? 35. And then the 5 gets left behind. Now, I'm going to say I will try to make sure you don't get numbers that big. Can I always guarantee it? They may slip by here and there, but this is a good strategy when you have really big numbers, is don't multiply them together. Find the perfect squares and the factors beforehand so you can simplify easier, right? Because what happens when I multiply 35 and 175? 35 times 175. Do I want to deal with trying to simplify that one? No, it's better to try to simplify them separately and then to figure it out. Make sense or doesn't make sense? Okay. Now, this is how it comes to play. I had some of you cut out these triangles, right? Does everybody here see 3 triangles? Yeah, we have a big triangle. I think of this as Goldilocks and the 3 bears. We have Papa Bear, Mama Bear is the medium one, and the small one is Baby Bear, right? We have 3 triangles. It turns out that these sides are all proportional because the people who got done early, I had them cut it out. They found that this angle here is the same as this angle over here. And this angle here is the same one as this angle over here. Right? Is that what we found out? And so we had 3 triangles with angles all having the same measure, which means they are similar. Similar means that I can make proportions. So it's not all about the base, it's all about the parts. It's all about the parts. If anybody likes that song. Maybe it's just me. Okay. We see here, we have a leg on the outside. I'm looking at the big triangle. We have another leg on the outside. This is the hypotenuse, and it's separated into segment 1 and segment 2, and you have the altitude. It turns out, and I'm going to do this by color, but I have a nice separate slide here, so don't worry about highlighting this or anything. Just watch for a minute. It turns out this leg here is what we call a geometric mean. This leg over here, I was going to do a different color, red. So this leg over here is also what? A geometric mean. And then the middle one is also it's a good color, it's different than the others. This one down here is also a geometric mean. With setting up the problems, when I say geometric mean, you see it up and you see it down. So you're going to see the same number or same variable up and down. So if I say geometric mean, you should think, oh, she's saying it's going to be up and down in my fractions, right? Everybody good on that part? Okay, so now, I'm going to go to the, where's the one? I'm going to go to this slide. This is the best slide of them all, okay? This one is if I was taking my test and I had a geometric mean problem, I would pull out this side. And now, if you have highlighters in your bag or colored pencils, now would be a good time to pull them out. If you need colored pencils, I have a big box of them over there, or I have some probably up here. Let me just take this out. Do you have any highlighters or colored pencils? Okay. Oh, I have a highlighter right here. Okay, so right here, it says EG. EG is in the middle. Everybody agree EG is in the middle? Yeah. So here's the middle. Choose a color and show that. And I'm going to color these here. Ah! I want to undo that one. Is there an undo? Oh, erase. It went too far. Why is it doing that? Stop that. I just wanted to do this little piece here. Oh. Okay. Okay. Now, I'm going to use a different color for DG. The DG is, I wish it would stop that. DG is from here to here. I don't know why it's doing that. I apologize. But then this is DG. Okay, now I'm going to use a different color for GF. Okay, so the hardest part about this is setting up the problem. If I am given EG, or I'm trying to find EG, EG is the geometric mean. Look in the fraction. Do you see EG up and EG down? Yeah. Okay, that's what geometric mean means. Now, DG is part of the hypotenuse, right? FG is part of the hypotenuse. Those are the two numbers or two segments you would use to set up the correct proportion. Sometimes we may have to subtract or add or do something else to find those pieces, because some of these end up being trickier. Not all of them, but some of them. Let's look. Now we're going to color code this next one. So which would I call the geometric mean on this next one? Which one do you see up and down? Which one? No. Which one here do you see up and down? DE, right? Do you see DE twice in this? Yes. That's your geometric mean. I don't know why it keeps doing this. So DE would be here. And you see DE here, and you see DE here. Okay. Now, what letter is DF? What is that? It's the whole hypotenuse. It's this whole thing right here. I wish it wouldn't do those lines on me. That's DF. That is the whole hypotenuse. What's DG? DG is part of the hypotenuse. I don't know why it keeps doing that. Quit doing that on me. I'm trying to help my students, and you're not cooperating. Okay, so DG would be part of the hypotenuse that it touches. Now, you'll hear me say that when students ask for help or when I'm setting up problems. Here is two parts of the hypotenuse, correct? Yes. If I am given DE, the two segments I use is the part it touches in the whole hypotenuse. Can you say that again? I need to find someone who can make songs and maybe put this in a song. So, if this is my geometric mean, the segments I would use would be the part of the hypotenuse it touches part and the whole hypotenuse. Okay, now this one flips. I have EF. EF is seen twice, right? EF is the geometric mean, the side it touches and the whole hypotenuse. It uses the two pieces of the hypotenuse is the one that comes from the center. All the others use the part it touches, whole hypotenuse. Geometric mean, I'll color code in a minute, part it touches, whole hypotenuse. Okay? And when I start doing problems, it'll make more sense because I don't have numbers here. But believe me, highlighting does help. And now I need to find my pen. Where did you go, pen? Oh, here it is. Okay, so EF is the geometric mean. I see it up and I see it down, right? Then I'm going to use the part it touches, which is right here, and then what? The whole hypotenuse. The whole hypotenuse. Do you see why I had you color coded? It does help make it easier to see. Okay. I'm going to try doing this again. Oh. Okay. So let's apply it. Agreed? We're going to start actually applying this. Okay, here it says AD is 3. I need a darker color because it's hard to see. AD is 3, right? Always mark what you know. If you don't mark up your triangles, you're not going to be able to do these. DB is what? 9. I have to find all 3 of these. So I'm trying to find CD, which is in the middle, right? So if I scroll up and look at my cases, which one am I going to use? Case 1, case 2, or case 3? Case 1. Case 2 and 3 are basically the same thing, by the way. They're just flipped around, right? So case 1, which means I use the parts. So CD, I'm going to have CD up because it's the geometric mean, CD down. The parts are going to be 3 and 9. Does it matter which place I put the 3 or which place I put the 9? No, because you end up just multiplying them together. So I could do 3 and 9, or I could do 9 and 3. When you cross multiply, you get CD squared is equal to 27. Then you take the square root, which would be 9 times 3, which would be 3. Square root 3 is equal to CD. Do I care about the minus? Because technically, I should put a minus, but no, because it's an actual side length, you throw the minus out. So CD is 3 square root 3. Did I lose anybody? Yeah. I give time for processing. Don't move. Freeze tag. Okay. Can I do the next one? AC? Okay. I'm going to highlight AC again. So now I'm finding AC, which is the outside. So what case would that be? Yeah, it'd be either 2 or 3. Okay. So we're saying case 3, which means I have to use the side it touches, right? Which side is AC touching? Here's AC. Which side is it touching? AD, which is 3. And then what's the whole hypotenuse? No, whole hypotenuse is not 9. Who said it? You are a genius. It's 3 plus 9. These are the pieces of the hypotenuse. The whole hypotenuse, you have to add those numbers together and get 12. So AC is the geometric mean. So I see AC up, I see AC down. The side it touches is what? What's the side it touches? What? 3. And then the whole hypotenuse has a value of what? 12. Now I'm going to cross multiply. I get AC squared is equal to 36. What's the square root of 36? AC is equal to 6 because I had to take the square root of both sides. So AC is 6. What's 9 plus 3? Because I needed the whole hypotenuse, I had to add 9 plus 3 to get the whole hypotenuse. And just to make me sound smart, that's called the segment addition postulate. Does it make me sound smart? But all it is add two little pieces to get the big piece. But segment addition postulate sounds smarter. Okay, now, am I ready to do BC?
No.
No.
Yes.
Am I ready now? No? Yes? Are they still talking?
Yeah.
Lucy, are you good? You good? Oh, are we good now? Okay. I don't mind waiting. Are you good? Okay. So now they want BC. BC is another geometric mean. Remember, geometric mean is the inside, which is called an altitude, and the two legs, right? And so BC is another geometric mean. So I see BC what? BC up, and I see BC down. I need the side it touches and the whole hypotenuse. What side is BC touching? Here's BC. It'd be 9, which is BD, and then the whole hypotenuse is 12. Why did I use 9? Because if this is CB or BC, I'm following it from the big 90 degrees, right? I'm coming here, and it's touching this part of the hypotenuse, and then the whole hypotenuse. So, if I cross multiply, BC squared is equal to, what is that? I'm going to keep it as 9 times 12 because I know 9 is a perfect square. I know 12 has a perfect square in it, right? You want to close that door because my foot, that may be helpful. What's the square root of 9? 3. What's the square root of 4? 2. And then the 3 has to stay behind. What's 2 times 3? So that'd be 6 square root 3. Now I could have multiplied them together and get 12 times 9. And then look for the biggest perfect square that goes in there, which would be 36. Which would be 36 times 3, which is 6 and 3. So you could multiply it out and then try it, or you could do the 2 factors. I think it's easier to keep the number small to simplify than to use the big number, right? Or no? Do I need to explain how I simplified this again? Everybody got how I simplified that? Why this is 6 square root 3?
Is there a shortcut?
That is the shortcut. Well, yes, the shortcut would be to use one of these calculators and it does it for you automatically. So if you have one of these,
Cheat code.
yeah, these do it. This one doesn't work, but that is the cheater way. But if you have one of those, I don't care. If you have the proper tool, you have the proper tool. You just can't use your phone.
Can we use it yesterday, ma'am?
What?
Yesterday, ma'am.
Yesterday?
Because like, what if we have these two?
Oh, use the Pythagorean theorem? Yeah? Yeah? You're smart. Did you hear what he said? He goes, well, if I have 6, can I use the Pythagorean theorem? Yes.
Wow.
Yes.
So we can use any.
Correct answer, yes. Not any answer, but the correct answer. Because that just proved Obed put it all together and synthesized it all. Wow. Okay. So let's look at this one. I start.
R and Q is 10.
Good. She said the exact same thing I was hoping. You're going to label what you know. What's ST?
15.
And what's QT? Oh, no, we don't have five. Oh, that's all we have. Okay, so this one, you do not have enough information. You're going to have to look. Oh, no, you have enough. No, you do not. Okay, so I need the side it touches and the whole hypotenuse, right? But the side it touches is QT, and I don't have QT. And then all I have is ST over here. I'm going to call this X. And then I'm going to call the whole hypotenuse X plus 15. Because I wasn't given all the information I needed, right? So I know that the three geometric means are RQ, RT, and RS. And so I needed to put X and X plus 15 because I didn't have everything. So I'm going to have QR up, QR down, but I haven't, because that's your geometric mean, but I know what QR is. What's QR? 10. So I'm going to have 10 up, and I'm going to have 10 down. The side it touches is X, right? What's the whole hypotenuse? X plus 15. Oh, I hope you remember how to factor or quadratic formula. Okay, what's 10 times 10? 100 is equal to X squared plus 15X, because I had to multiply these two together. X times X plus 15 is X times X is X squared. X times 15 is 15X. So then I'm going to do X squared plus 15X minus 100 equals 0. Which would you rather do, factoring or quadratic formula? Factoring. I need my big X, two numbers that multiply together to equal 100, and when you add them together, they equal 15. So what is it going to be? Let's see, this is ceiling, this is basement, negative 100. Oop, that needs to be a B. This is 15. What did you tell me? 20 times 5. This needs to be minus because this one has to equal. So it'd be X plus 20, X minus 5 equals 0. So X could equal negative 20 or X can equal 5. But in this situation, what am I going to use? Minus 5 here, minus 5. But when we solve, we know X minus 5 equals 0. So X has to be 5. For this one, X, when we solve, X plus 20 equals 0. So X would have to equal negative 20. We get rid of the negative. So what's QT?
5.
QT is 5. So QT is 5, right? What's the whole hypotenuse then? 5 plus 15 is what? 20. So now could I find RS? I don't have to do anything fancy to find RS. I'll let you guys finish writing. And you thought you didn't need to factor anymore. I don't think I threw any of those on your papers. But it is good to see that sometimes you have to know how to factor. Mr. Adam would be so proud if he was in here, wouldn't he?
Yes,
He would. He'd say, oh, Miss Dawn did factoring today in geometry. Okay. What case is RS, by the way, if you look back in your notes? Is it going to be case 1 or is it going to be case 2/3? 2/3, right? Because it's the outside and it'll be the side it touches and the whole hypotenuse. But now I have all those numbers, right? Because what's the side it touches? Side it touches is 15 and the whole hypotenuse is 20. So oh, that doesn't look pretty. Let's see. RS up, RS down. I have the side it touches, which is 15. I have the whole hypotenuse, which is what? 20. Because 5 plus 15 is 20. And then I'm going to cross multiply. RS squared has to equal the square root of 20 times 15. Now I do that to make it easier to simplify. Is there any perfect squares in 20? 4 is a perfect square. So 4 times 5. What about 15? 15 doesn't, but I know that there's a 5 somewhere in there, right? So the 4 comes out as a 2, but I have 2 5s, which together they come out as 1 5. No, 5 times 5 is 25. Square root of 25 is 5. Out here is 10. Square root, what's left is 3. 2 times 5 is 10. The leftover factor is 3. So this is RS. And of course, we only use the positive in geometry. Now, if you had the if you had the other calculators, or Man has one. Man, did yours simplify? Yeah, if you just took 20 times 15 and then took the square root of it, your calculator just does it for you. Yeah, it just pops up.
Wait, miss, wait.
Oh, I was just looking, sorry.
Sorry. Okay, we're good. Okay, we're good.
I know, but she's asking Peter a question, so I'm waiting. That's my weakness. Or chips. I don't know. I can't. I gotta stay away from sodium. My blood pressure is starting to get bigger. Are we good now? Peter, did you explain it? Do you understand it? Can he just do it himself? Okay, let's label what we know on this next one. 20. 10. Okay, who here plays strategy games like cards or board games or all of it? Okay. It says here to find AC, which AC, I don't have all the information yet because I'm missing AC. I'm missing the whole hypotenuse. I can't do AC first. Can I do BD first? Yes, because DC is case 1. where I need the two pieces of the hypotenuse, and I'm given this as my geometric mean. So this is the geometric mean of these two pieces. Look at case 1 if you don't know what I'm talking about. Right? So I wouldn't start trying to find AC. I would start by trying to find BD, because that's good strategy. That's deductive reasoning and critical thinking skills, which geometry is supposed to be helping you with. So if CD is the geometric mean, that means where do I place it in the proportion? No, it'd be CD up and down. Because if you look back here, if you look back here, that altitude in the middle is the one you see up and down. And it's the two pieces that are in the other spots, right? Okay. That's why this is really powerful, especially if you color coded it, because that just tells you how to set up your proportions accurately. So in this case, it'd be 20 up, 20 down, because this is the geometric mean. 10, and then BD. So this would be cross multiplying 10 times BD has to equal 400. I divide both sides by 10. What does BD equal? 40. So it made sense to find BD first. Now I could find AC, but I have to figure out what the hypotenuse is. But I have all the information to figure out what the hypotenuse is. What's the hypotenuse? The hypotenuse is 10 plus 40, which is 50. You had to take 10 plus 40 to get the 50, right? Because this was 10. We found BD to be 40. The whole hypotenuse is going to be 50. So if I'm trying to find AC now, right? The AC is a geometric mean. Now we're looking at case 2/3 in your notes, where AC is up. Yeah, this is case 2. Do you want me to go to it? Or 3. This could be also considered 3. It's the outside leg. And AC down. And then it's the side it touches. And then the whole hypotenuse. So 10 and what? 10 and what? 50. The whole hypotenuse. Now, not 40. That's where students make the mistake. A lot of times they don't give me the whole hypotenuse. They set up the proportion incorrectly. So now we do AC squared is equal to the square root of 50 times 10. What perfect square goes into 50? That's not a perfect square. 25 times 2. 25 is a perfect square. But I also know 2 goes into 10. 2 times 5. These two together comes out as 1, 2. But 25, what's the square root of 25? 5. And that 2 has to come out, right? And then square root of 5 is left behind. What's 5 times 2?
10.
So 10 square root 5. Did I find it all?
No. DC.
Okay, so then now this is case 2/3, but I'm finding the other outside leg. Right? I'm finding the other outside leg. So it's the side it touches. Oh, why? It's the side it touches and the, let me try. I know, but it doesn't, this thing does not want to cooperate. Next time I'll try using Cami. Maybe Cami will cooperate better. Oh, well, we're getting a big blue streak. Sorry. I try. Okay, so which is the geometric mean? BC is geometric mean, which means I see it what? I see it up, and I see it down, and then it's the side it touches and the whole hypotenuse. Here's BC. When I'm talking about the side, we're talking about this hypotenuse here. Which segment is it touching, the 40 or the 10? The 40. And then the whole hypotenuse is what? 50. So BC squared has to equal the square root of 40 times 50. Is there a perfect square that goes into 40? 4 times 10. Is there a perfect square that goes into 20 or into 50? 25 and 2. So I'm going to do this. I'm going to break it apart because I think I'll lose people if I do it all at once. So what's the square root of 25? That comes out, right? What's the square root of 4? And that comes out as 2. So I have 5 times 2 with 10 times 2 underneath, right? What's 5 times 2? 10. The problem is 10 also has a 2 in it, doesn't it? That's 2 times 5. So these 2's can come out as another 2. So what's 2 times 10? 20. And what's left behind? 5. No, that's just the 5. So it's 20. It's 20 square root 5. Yeah, if you don't know your multiplication facts, higher and higher math gets really, really difficult. So, moral of the story, Michelle, before we take the test, you come up and you say, Miss Dawn, can I please use one of those blue? And I'll go, yes, Michelle, you can use one of the blue calculators that I have. If you really, I only have like 3 or 4 of them that work. But if you really need them, I try to save them for the ones who can't do it. If you don't know your multiplication facts, come talk to me about using one of the blue calculators that I have, not those blue calculators. Okay. We just have one more, correct? Do you want to let me let you try and do 5 on your own? You all try and do that one. I'm going to do it on my little scratch paper here, and we'll see if you can do it. Remember, use your case charts. Your case charts tell you how to set it up. Think to yourself, is this case 1? Is it case 2? Or is it case 3? And then you set it up that way, right? And always, always mark what you know. Oh. Get this, I'm going to do it up here while she's handing out those. EF is 8. DG is 12. FG, I'm going to put X, and this whole hypotenuse then has to be X plus 12. This is one of those that I'm going to have to factor. So I get 8 up, because 8 is the geometric mean of the side it touches and the whole hypotenuse. So it's going to be 8 up, 8 down, X, and X plus 12. I cross multiply, I get 64 is equal to x squared plus, oh, I dropped my 12 there, 12x. I need to get this set equal to 0, so I could factor or use quadratic formula. Either way would work. If I use factoring, this would be negative 64 up here, 12 here. It would be negative 4 and 16. So x minus 4, x plus 16 has to equal 0, x equals 4, or x equals negative 16. I throw out the negative because we're talking about a side length. So FG is equal to 4. EG, now I can do EG because I have the two pieces. So EG is a geometric mean, EG up, EG down. It'd be the two pieces. This is case 1, 4 and 12. EG squared is equal to the square root of 12 times 4. 4 is a perfect square. That comes out as a 2. 12 is 4 times 3, so 4 comes out again as a 2. So you get 4 square root 3. And that is EG. So EG is 4 square root 3. DE would be DE up, DE down, because again, it's the geometric mean on the outside. It's the side it touches, which would be the 12, and the whole hypotenuse. Since x is 4, the whole hypotenuse is 16, because 4 plus 12 equals 16. So DE squared is equal to the square root of 16 times 12. 16 is a perfect square. That comes out as a 4. This is 4 times 3. Square root of 4 comes out as a 2. So I get DE is equal to 8. 2 times 4 is 8. Square root 3. 8 square root 3.